Okay. So to recap, we're solving systems of linear equations, and that is basically in the homework and in the test, we're going to be given two equations, two linear equations that we could, in theory, graph simultaneously, and that might look something like this. So here's an example of a system, and that system might be written like this. Sometimes it has the brace, sometimes it doesn't. But really, it's just the two equations, like 3x plus 2y equals 11, and negative x plus y equals 3. Right? And this might represent some real world problem, right? Like we talked about over a week ago. Examining two different fitness plans, one for Planet Fitness and one for the YMCA, and how we could construct those to be a system of linear equations. And that when we got that solution, the solution, at least its graphical interpretation, is the intersection of two lines on a graph. So if I had one line going up like this, and maybe I had another one that was a little less steep, like so, the solution is that intersection for those two graphs, right? So if you had a graphing utility like I did when I went into Planet Fitness and they were trying to sell me on these two different plans, I was able to throw those two plans into my calculator, figure out where they intersected, that is where the prices were the same, and figure out how long, basically in the long run, which plan was least expensive, right? Based on how many months that I was trying to be a member of that gym, right? Okay, so there's systems of equations can be used to model real world problems, and they can actually help you save some money if you know how to use them. And so far we've learned the substitution method, for solving the system of equations, and we've learned the elimination method. Okay, so I want to recap the elimination method again, because I think it's going to be a natural segue into the Gauss-Jordan or matrix method. Okay, so if I wanted to solve this equation or this system of equations, then what you should be thinking to yourself is, okay, I can take these equations and add them together if I wanted to. I can also multiply an equation by a number, and it doesn't change the fundamental character of these graphs. Okay, so what I'm trying to do is you want to multiply one or both equations by some number, and that's going to be the tricky part, right? Trying to figure out what number to choose. But you could choose really literally any number except for 0, and you would be fine as long as you carried out that multiplication correctly. But we're going to choose some number to multiply one or both of the equations by, so that the coefficients match, but with opposite sign. And the opposite sign is the super important part, because this thing is called the elimination method. So the idea is that we're going to add the two equations together and something is going to eliminate, but they'll only eliminate if I can match these coefficients or these numbers in front. Okay. Like if I wanted to cancel out a positive 3x, I would need a negative 3x here, right? That's if I was focusing on the x's. And if I wanted to cancel out this 2y, then I would need a negative 2y here. so that I could cancel out the y's. Now that's two different ways of doing it. You can choose to eliminate the x or choose to eliminate the y, but you're only going to choose one of those ways. Either way you choose, either path you take, you will get to the same endpoint. You'll find the exact same solution. Okay, so let's take equation 2. So you could think about this as, well, let me call this equation B. Since I'm using 1 and 2 here, I'll call this equation A, and I'll call this one equation B. So let me take equation B, and if I wanted to cancel out the x, I could just multiply equation B by 3, right? Does everybody see why that is? Or is there anybody who doesn't see why that is? Why we wouldn't multiply by 3? Okay. So I'm going to flip the page and write this equation again. What do we have here? It's 3x plus 2y equals 11, negative x plus y equals 3. Okay, and what I'm doing is I'm taking this equation and I'm going to multiply it by 3. So I throw parentheses around the equation, and then I'm going to distribute or multiply that 3 by every single term in the equation. And then I might walk over here to this side of my page. I'll leave the first equation alone, 3x plus 2y equals 11. We didn't do anything to the first equation. But that second equation should now be 3 times negative x is negative 3x. 3 times positive y is positive 3y. 3 times 3 is 9. Okay. And then we want to go ahead and add the equations to eliminate something. Well, if I add these equations together, and I'm just looking at the x's here, 3x minus 3x, or 3x plus negative 3x, we can say those cancel out. So they give us 0. We don't have to write the 0. And we can just go ahead and combine like terms for the rest of the equation. So 2y plus 3y is going to be 5y, and that's going to be equal to 20. Have I lost anybody? Is everybody okay with this? Is there anybody that's not okay with that? Okay. So now if we pick back up at this 5y equals 20, this is a simple linear equation with a single variable. So all we're going to do is divide by 5 on both sides so that we get y is equal to 4. Okay. But you have to remember that when we're solving this system of equations, the solution is going to be the intersection of these two graphs. So the solution here, it has to be written as an xy pair in parentheses, right? Because it's an ordered pair. It's a location on the graph. So just because we found y doesn't mean that we're done. We have to find the corresponding x value. Okay, and we can do that by just taking the y of 4 and then substitute it back into one or the other equation. Okay, so now we can back substitute into, let's just go with equation 1, just because it's less messy. Or we were calling that equation A, weren't we? Okay, well, if we plug 4 in here, we'll get 3x plus 2 times 4 equals 11. So we can start simplifying this and solving for x. So 2 times 4 is 8. And then to solve this, we can subtract the 8 over to the other side. So we'll have 3x is equal to 11 minus 8 is 3. And then I can divide by 3 on both sides here, and I get x is equal to 1. So my solution in MyLabs Plus will be written like 1, 4. They'll give you the curly braces, but you do need to put your solution as an ordered pair enclosed in parentheses, where the x comes first and then the y comes next. Does anybody have any questions about that? Or was there any point of confusion on that elimination process? Okay. Well, now that we have this solution, I want to work on this problem again, but this time we're going to talk about it in terms of how would we go about solving this as a matrix problem. Okay. So a system of linear equations can be written and solved as an augmented matrix. Okay, so oftentimes you'll just hear me refer to these things as matrices or a matrix. I won't say augmented matrix. The only thing that makes it an augmented matrix is that, well, you'll see here in a second. Let's write down this equation. 3x plus 2y equals 11, and negative x plus y equals 3. Okay. Well, in order to write this in terms of an augmented matrix, all we're going to do is store the information that's given to us by the coefficients. That is, the numbers in front of the variable, or the numbers that are in the system of equations. And what we'll do is store them into this little block of code, or this block of numbers, that represents this set of equations, but leaves out some information, right? So instead of writing x and y over and over again, we'll just write 3, 2, and 11. Okay, but we have to remember that this matrix represents this system of equations. So this first column for this first row corresponds to this first equation, right? And then if I wanted to write the second equation in this matrix, I would write -1, +1, 3. Is anybody confused why I wrote -1 and +1 here? Okay. Well, I wrote the -1 here because the coefficient in front of this x is -1, and the coefficient in front of this y is a +1. So we went ahead and stored that information in our matrix. Does that make sense? Okay. Now, where we have the equal sign, we'll typically write just a straight vertical line here. So you can think about this matrix as storing all of the information from our system we have x here. Our column represents the coefficient for the x's. The y coefficients are stored in the second column. And then the constants are stored in the third column on the opposite side of the equal sign. Okay. Well, now I want you guys to get some practice converting a system of equations to an augmented matrix. That's going to be the first step. So these are the basic building blocks, right, that we're going to build up to solving a system of equations with matrices. Basic steps. 1, we need to convert the system to a matrix. So here will be our first example. And I'm going to write this down and then throw you guys into some breakout rooms. Oh, my bad, not B. That's the first equation. The second equation is this. Okay. So we need to take this system of equations, these two equations, and convert it into a matrix. Okay, so take some time to do that. I'm going to throw you guys into breakout rooms. And you guys just, if you get stuck, discuss it with your peers, and I'll be in there to check on you in a moment. Okay, so the breakout rooms have been created. Go ahead and accept those once you get a chance. So I knew that that wasn't going to take very long for some of you guys. All you have to do is remember that we need both equations in standard form. And then it's just as simple as taking the numbers right out of the equation, right? So standard form, if you recall, look like ax plus by equals c. So we have to get the x and the y on one side of the equation and then throw the constant over to the other side using all the principles that we've learned about manipulating linear equations. So if I wanted to move this 32 over to the other side of the equal sign, I would need to add 32 here and add 32 there so that this cancels out. And my equation would be, well, I would have negative 2x minus 2y equals whatever it was, negative 16. And then the bottom equation was 4 and negative 32. Well, that's going to be 4x plus 4y equals positive 32 now that I've thrown the 32 over to the other side. So my matrix, my augmented matrix, and this is just an arrow symbol. A student in tutoring earlier this morning asked me what that symbol was, and it's just an arrow. So don't think that that's a special character or something. Anyway, the matrix is just going to be extracting these numbers from the rows. So negative 2, put my vertical line for the equal sign, negative 16, 4, and positive 32. Are you guys okay with that? Cool. Let's look at a different example, just converting it into an augmented matrix. I won't use the breakout rooms here. I'll just give you guys a few minutes, but let's go ahead and turn this one into a matrix. So we have 8x plus 9y minus 28 equals 0. And then we have 5y equals 20. That's my system of equations, okay? So take about 1 to 2 minutes to figure out how do I write this as an augmented matrix. Has anybody figured it out already?
Is it 8 on top, 9 on top, 28? And then on the bottom, I'm kind of guessing 0, 5, and 20.
I put 1.
You put 1 in this position?
Yes.
Okay, so that's a good guess, right? I know that we're sort of feeling like we're guessing a little bit, but you have to ask yourself, like, how many x's are here in the second equation?
None.
And if there are none, then that's a 0.
Okay.
So just remember that, let me say, recall that the matrix
Only if
is,
there's like the variable, right? That's
yeah,
when it
this is
becomes
x,
a 1.
this is y, and then this is the constant. So if you don't have any x's, it'll be a 0. And maybe I'll just fill this up with A, B, C, D, E, F. Just to complicate your life a little bit. Again, mathematicians just use letters to say, like, I don't know, something could go here, something could go there. It's not really important. The numbers change. But the structure, the overall structure is that if you have x's here, you put those coefficients there in the first column. But the rows correspond to the equations, right? So it's pretty natural to say, okay, in the second row here, my equation is 5y equals 20, right? And the first row corresponds to the equation. Even if I wasn't looking at this, 8x plus 9y equals 28. And that's like the nice thing about taking this information and then just sort of like condensing it into a small block of numbers. Okay, so we know how to then switch our system of equations into an augmented matrix. But just so that we can, make sure that we're adept and flexible at doing that exercise, what I want you to do now is convert the matrix to a system of equations. So let's call this C, and I don't know why I did this brace. Let's go ahead and give you a matrix with 10, 5, and 18 on top. That's an 18. Now it's an uglier 18. And then 14, 15, and 16. What would the system of equations that generates this matrix, what would that system look like? I'll give you guys about a minute to throw that together. Does anybody want to just give their, I'm sure that somebody has gotten it already, but does anybody want to give the system of equations?
Is it 10? Oh, oops. You can go ahead.
No, you go ahead. It's fine. Thank you.
10x plus 5y equals 18. And then 14x plus 15y equals 16.
Yeah, perfect. Does this seem like scary at all? I mean, it feels a little bit strange at first because, you know, anytime you learn something new, it feels a little bit strange. But, you know, these are like the baby steps. We're dipping our toes in, and then eventually we're going to dive into the deep end. But for now, you know, we need to learn how to doggy paddle before we go in there and start doing the breaststroke. Let's go ahead and ABCD. Convert this matrix into a system of equations. -2, -8, 6, and 2, -9, -6. And if you guys want to just like think this one out loud and tell me what it is, I think that we're starting to see it's pretty easy to go from our matrix to our system of equations.
-2x minus 8y equals 6.
Mm-hmm.
And 2x minus 9y equals -6.
Boom. Is anybody still like apprehensive or confused or scared about converting a matrix to a system of equation? Okay, cool. Well, just like the elimination method, we can multiply the rows of a matrix by any non-zero number. It could be a fraction, it could be a decimal, it really doesn't matter. There's going to be some smart choices, and we'll figure that out here in a little bit. But what I want you guys to do is take this matrix 4, 20, and 16, 4, 2, and -4. And we're going to do what we call a row operation. A row operation is a set of instructions that tells you exactly how to manipulate the matrix. So if I gave you the row operation, for instance, let's say row 1 is equal to, for no reason at all, 3 times row 1. This is like the set of instructions that you might receive in your homework. And the way you want to read this is, this part is telling you the new row 1 is equal to multiply the original row 1 by 3. Now, the tricky thing about matrices is that they have a lot of scratch work that you have to do to the side. So what I would say is you might want to like visually or even like write a little division line so that you can do that scratch work. And when I say division line, I just mean like a line dividing your piece of paper into 2 sides. Okay, so we're going to do our scratch work over here. The instructions say take the number 3 and multiply it by row 1. So what I'm going to do is take row 1 only, which are the numbers 4, 20, and 16. I'm not going to put any operations between them. I'm just going to take the numbers. And I'm going to throw parentheses around them and multiply each of them by 3 as instructed here. And you can think about it like distributing a 3 to that row. Each item in that row gets multiplied by 3. So we should get 12, 60, and then whatever 3 times 16 is, 8, 1 up, 3, 48.
Isn't it 48?
Yeah. Yeah. And this thing here is our new row 1. So all I'm going to do is, if I'm told to do this row operation, is take my matrix and rewrite it, but I'm going to replace row 1 with these numbers: 12, 60, 48, and leave row 2 alone. So we'll just put 4, 2, and -4. Any questions about that process? Like I said, it should feel a little bit familiar, because
So you just chose 3 at random? Like,
yeah, I just chose 3 at random.
Okay.
You're going to choose something that's not random, but just to get used to doing row operations, I just arbitrarily chose 3.
Got you.
But notice that when we did this elimination method in the first problem that we did in class today, I said, let's take equation 2 or equation B and multiply it by 3, right? That's like taking a row and multiplying it by a number. Now, the reason why we chose 3 here is because we wanted to eliminate something. So there was a reason for choosing 3. There will be a reason for our choices when we start solving matrices. But for now, I just want you guys to get used to performing a row operation arbitrarily, right? Just at random. Because you'll have some homework problems that'll say, do this row operation. And that's it. They're not asking you to solve it. They're just saying, take this number, multiply it by this row. Okay, so I want to take this same matrix and have you guys do a row operation. I'm going to use numbers now because why not? I'm going to give you this same matrix, 4, 20. This matrix obviously loves to party. So 4, 20, 16. Then we have 4, 2, and -4. And I want you to perform this row operation. R1 is equal to, wait for it, 1/4 times row 1. Okay, so take a moment, maybe a minute or 2, and then tell me what you get for the resulting matrix. Now here's a pro tip. If you're only manipulating row 1, your answer, you can automatically just rewrite row 2 because we're not changing row 2. Just focus on the numbers in row 1. And let me go ahead and draw a little line, and we can do scratch work over here. Okay, that's my tip. I'll give you guys a minute, or whenever somebody has their row operation complete, go ahead and tell me what the new row should be.
I believe it's 1, 5, 4.
Yeah, perfect. Okay, so that's the same thing as taking 1/4 and multiplying it by 4, 20, and 16. And when we do that, 1/4 times its reciprocal is going to be 1. Multiplying by 1/4 is like dividing by 4, so this is just 5. 16 divided by 4 is 4, right? So this is, this guy is the new row 1. So I'll just go ahead and make that replacement. 1, 5, 4. Does anybody have any questions about that? Or is anybody stuck, just absolutely floored or confused? Okay. Well, multiplying a row by a number is not the only kind of operation we could do. We could also add 2 rows together. So let me give you a new matrix. Well, let's keep working with the same matrix. And we have 4, 2, and -4. And the row operation that I want you to do is replace row 2 with R1 plus R2. You know what? Not plus. Go ahead and subtract those. Okay, does anybody have a solution or has completed this row operation? Or does anybody have questions about how to go about doing this operation?
I have the new row 2.
Yeah, what's your new row 2?
0, 18, 12.
Yeah, let's take a look at this. So if we're subtracting, we're taking row 1 and subtracting row 2. So that would be 4, 20, and 16. And you can line them up the same way that they are in the matrix. And we're going to subtract this second row, 4, 2, and -4. So 4 minus 4 is 0. That one's good. 20 minus 2 is 18. So that one's okay. But what is 16 minus -4? That one's a little bit trickier. Well, if you're subtracting a negative, you're really adding. So this one is off, but that's okay. 16 minus -4. 16 minus -4. -4, just parentheses for clarification's sake, is positive 20. Does that make sense? So if you are subtracting row 2,
So you are kind of multiplying the negative.
yeah, you can think about it that way for sure.
Okay.
Right, because when you subtract a negative, we often say, right, like a negative and then you subtract a negative, let's say A minus negative B. In our heads, we just say, oh, that's really A plus B. That's a simpler way to think about it. But another way of thinking about it is that this is -1 times negative b, which is positive b. So really you're adding. So when you subtract a negative, you're adding, right? And so you just have to be careful with that. So our resulting matrix, again, we're only changing R2, so R1 stays the same. Will be 4, 20, 16, and 0, 18, 20. So when you do that subtraction, if you're subtracting a negative, you'll want to think about distributing that negative sign and then just adding, right? Any questions or comments there? All right, I got some more row operations coming at you. Here's a new matrix. We have 1, 2, and 10.
We can't see it.
Oh, my bad. 1, 5, and -3. Let me go ahead and write this first before I give you the operation. Now, the operation I want you to perform is row 2 is going to be equal to -1 times row 1 plus R2. So there's 2 operations here. So take your time, take a couple of minutes, and then tell me what the new resulting matrix should be. I see some people lifting their heads. Does anybody have a possible answer for this operation?
Got 0, 3, and -13 for being the new row 2.
Cool. So it would be we're thinking, you said 0, 3,
Yes,
and negative 13?
yes.
And then row 1 you left alone?
Yeah, 1, 2, and 10.
Did anybody else get this?
I have
Yeah, that's what I
0,
got.
0, minus 6.
Yvonne, what did you say you got?
0, 0,
0, 0, and the bottom?
minus 6.
And that was
Yeah,
for
yes, row 2.
0, 0, minus 6.
Yeah.
Okay, and then you left row 1 alone?
Yes.
1, 2, and 10. Anybody get something different?
I got 0, negative 3, and then 13.
That's pretty close to this first one, right? And everybody, I assume, is leaving row 1 alone. Okay. I think we're on the right track here. Let's go ahead and jump in. What I would say is treat this as 2 operations that you're doing separately. Okay, and just take your time as you walk through this. So what I would do is write -1 times all of the numbers in row 1. So you might focus on this first. So that's 1, 2, and 10, and then the result of that would be -1, -2, and -10. Okay, we're not replacing.
I'm sorry, my answer is incorrect because I multiply for row 2.
Oh,
So
okay.
I don't have my glasses. I always make mistakes with it.
Oh, I'm so sorry. Yeah,
The little numbers.
that's okay. Just be careful next time. Try to have those glasses handy.
Yes.
But then we go ahead and finish up this operation. So I have these numbers, and I'm just going to add row 2. And those numbers for row 2 are just 1, 5, and -3. And this is just straight addition. So -1 and 1 should be 0. -2 and 5 should be like 5 minus 2 is 3. And then -10 and -3 should be -13 when you add those. So it looks like this should be the correct matrix there. Okay. Now I'm not exactly sure how we got this one, but this one technically is not wrong. But maybe if you could, who was the one that got this one as their matrix? Can you walk me through your process? Did you find your mistake?
Yes, I'm actually trying to see what I did because I have exactly, my first step is -1 and then parentheses 1, 5, and 3.
Uh-huh.
And then my resolution is -1, -5, +3.
Wait, walk me through that one more time. I'm sorry, I got lost.
It looks like I used row 1.
Yeah.
I'm sorry, I used row 2 and multiplied row 2 by -1.
Oh, okay.
But I still added row 2.
Oh, okay, that's strange.
So I did
Yeah.
-1 row 2 plus row 2.
Yeah, it's best to not even think about that. Just do it using this process and we should be good. Let's not worry about this because I don't want to confuse people any further. But right, we're doing this operation first. And again, like I said, there's a lot of scratch work here. You end up with this block or this new row that you're just using temporarily to add to row 2. And then what you end up with, per our instructions, right, is the new row 2. So we leave row 1 alone. Okay. Do you guys want another row operation where you have more than one operation to do?
Yes.
Okay. I'm gonna go back to our, I keep thinking of this as the party matrix just because of the 420 here. Okay, 420, 16, 4, 2, and -4. And what row operation do I want you guys to do? Let's see. Row 2 is equal to negative row 2 plus row 1. And let me zoom in. There we go. I don't want to lose anybody because I'm not zoomed in far enough. So take a moment to perform that operation, that set of operations. Remember, take your time, do this part first, and then take whatever the result of that is and add it to this part, okay? Okay, has anybody completed the operation yet?
I did.
All right, let me walk through this one and then I'll ask you if we got the same thing, okay? So a lot of times what I will do to like forego writing some of the scratch work to the side, I will just focus on one operation at a time. So I'll think about this like, okay, I'm gonna change R2. Let me zoom out a little bit so that I don't lose you guys. Zoom out, there we go. I'm gonna change R2. So I'm gonna sort of look at R2 and this says negative R2. So I'm gonna multiply that by a -1 or just throw a negative sign in front of it. So I might write the resulting matrix just by multiplying the -1 here. So I'm leaving R1 alone. And I'm just gonna do the first step here of multiplying this to get -4, -2, and then +4. Is that what you guys got for your intermediate step? Okay, now I'll go ahead and take care of adding the two rows together. And whenever I add two rows together, I feel like it's really convenient to go ahead and write those numbers off to the side, because we'll have to add it up and it sort of gets really messy. So 4, 20, 16, and then we're adding -4, -2, and +4. We're adding these things. So a positive and a negative, when you add them, will cancel out to some extent. This one will cancel completely to a 0. This will cancel to an 18. And then we're adding 4 here, so that's going to be a 20. Okay, so my resulting matrix, if this is supposed to be my new R2, I'll leave row 1 alone for 20, 16. And is this what you guys got? 0, 18, and 20? Okay. Good. Anybody get something different? All right. Well, let's say that I wanted to just continue working on this matrix, this one here that I've gotten as a result of this operation. And let's say that I wanted to, for whatever reason, tell you that the next operation I want you to do on this resulting matrix is I want you to take the row 1 and I want you to multiply it by 1/4 again. What would the next matrix be? And just for, I guess just for fun fact, I don't know exactly what I'm trying to say, but multiplying by 1/4 is the same thing as taking row 1 and dividing by 4. So you could do either of these operations and you would get the same result, okay? So what should this new matrix be?
1, 5, 4, row 1,
5, 4.
and the second leave it the same.
Is everybody okay with that?
I got the same.
Okay. Next, let's say that I asked you to take row 2 and I wanted you to multiply it by 1/18 by row 2, which is the same thing as asking you to divide by 18, okay, just to be clear. What would the resulting matrix look like then? If you get a fraction, that's perfectly okay. Just make sure that the fraction is completely reduced or simplified. Does anybody have the resulting matrix yet?
I got on top 1, 5, and 4, and then on the
Good.
bottom I got 0, 1, and 1 and 1/8.
1 and 1/8. 1 and 1/8.
No, I'm sorry. Yeah,
I'm feeling like 20 divided by 18 is a decimal, right? But if I convert that to a fraction, it should be 10/9, which would be 1 and 1/9. But we're going to leave that as a improper fraction and call this 10/9. Is everybody okay with that? Are we on board now?
can you show me how you got the 10/9?
Yeah, for sure. So like I said, when you multiply by this fraction, by these whole numbers, you're
Right.
basically making this the denominator for this 20. Right?
Okay,
So you would have 20/18, which if you divide both of these by 2, you get
Okay.
10/9.
I got you.
Yeah. And 18/18 is going to be 1, so that's how we got this guy. Okay, so we have this new resulting matrix. And I'm going to keep on working this guy. So what do we have? 1, 5, 4? Is that what it is? And then we have 0, 1, and 10/9. Well, now I want you to do this operation. So I want the new row 1 to be equal to, let's do -5 times row 2 plus row 1. Let me zoom in so we can see what I want you to do. Sorry about the glare. There we go. It'll take about 2 to 3 minutes to try to do this set of operations. And remember, take your time multiplying this number by the second row because you will have to do some matrix, some fraction multiplication here. Maybe I didn't want to do that. That's fine. Let me go ahead and cross this out. Let me just do my scratch work to the side. So if I multiply this out, did we get 0, -5, and Lord, -50 over 9? And now I need to add that to row 1. 1, 5, and then 4. We're adding all of those. So I get 1, 0, and then whatever this monstrosity is, obviously you guys are able to use a calculator to help you out with that. But you know, if you have to do it by hand because you're not sure how to get fractions in the calculator, you can do that for sure. -50 over 9 plus 4 over 1, but we need a common denominator. So what I might do is go in here and multiply this guy by 9 over 9 so that I have 36 over 9 plus -50 over 9. And then this is just -50 plus 36. -50 plus 36. We can do that in the calculator. I get -14 on top. And then denominator of 9, and that doesn't reduce. This is the guy that we want.
Will we have fractions on the homework?
Sure, why not? They're numbers like any other.
Okay.
So what we can do then is say, I said we had this matrix, we did these operations. So what we should end up with is what we're changing row 1 to this guy. 1, 0, -14 over 9. And then this is 0, 1, and 10 over 9. Seems a little crazy, right? The kinds of operations I was asking you to do there. Seemed like it had maybe there was no purpose or reason for these particular operations. And then when fractions came into the mix, it just became like really scary. But what we call this, when we have a matrix that looks like Swiss cheese, so we process down the matrix, doing all of these seemingly random row operations, and then we end up with Swiss cheese, which is what I like to call it, because mathematicians call it reduced row echelon form. But we can just call it Swiss cheese. Okay. Can anybody take this this matrix and turn it into a system of equations?
I mean, I don't know if like 1x.
Or just x?
Okay, x equals minus 14, 9.
Yeah, 14 nines or 14 over 9, yeah.
And then y equals 10 over 9.
Yeah. So when you have the matrix in Swiss cheese form, you've essentially solved it. The solution for this system of equations that's represented by our matrix is this weird ordered pair -14 over 9, comma, 10 over 9. So if you can process the matrix down into quote unquote Swiss cheese, then you're effectively solving the matrix using what is called the Gauss-Jordan method. So I'm just going to give everybody a chance to write this down, because we started off with this matrix here, right? Which we could write as 4x plus 20y equals 16, and 4x plus 2y equals -4, right? And give me just one moment. As I struggle with my computer to open up Desmos. Or not. There it goes. And we can see, what is the intersection of these two lines when we graph it? Well, it should be at this point, -14/9, comma 10/9, which, just to make our lives a little bit easier, -14 divided by 9 should be right around -1.55 repeating, comma 10 divided by 9 is +1.11 repeating. So it's like, should be pretty close. I'm putting little squiggly lines because we should be pretty close to that ordered pair. And my Google Chrome is taking forever. Okay. Awesome. I really want to show you guys what this looks like, but my technology is being really bratty right now. So you're just gonna have to take me at my word. If you guys were to throw this into Desmos, the original equation or this final equation, you would get this ordered pair as the solution. So what I want to do is like take a 10-minute break, and then we're gonna solve some of these matrix equations from start to finish. So let's say we come back at 1:50, and then we'll do a couple of examples. Resume recording. Okay. Okay, so what I'm going to do is start us off in a system of equations. And so I want to solve using the Gauss-Jordan method. Again, just a fancy way of saying solve using a matrix. So this is going to be the system that I'm going to give you. X plus y equals 5, and x minus y equals -1. So I'm going to sort of walk you guys through this one. I'm going to be asking you questions, asking you for input on what you guys think I need to do. But I'll be doing all of these, and then I'll give you guys a set of problems to work in groups. Okay. So just to start off, as soon as they tell us, solve using the Gauss-Jordan method, we need to throw this into a matrix. So what we might do is, and I draw a lot of arrows for this. I'm just going to go ahead and throw this into the matrix. And what should the first row of the matrix be?
1, 1, and 5.
Yeah, 1, 1, 5. And the second row?
1, negative 1, negative 1.
Negative 1, negative 1. Yeah. Is anybody lost on that? Okay. So the first thing to do, it might be to like rearrange the equations so that they're in standard form, but we were already in standard form to begin with here. So we could just convert the system to a matrix. Okay. Now what I would do is think about what operation will eliminate this position here. Okay, and what I mean by that is what we want to do is get, I'm going to say get our zeros first. And so you might be thinking eliminate something somehow. Now remember, the rules that we can use here are the same as the rules for elimination. So our row operations are that we can multiply or divide a row by a number. We could add or subtract rows together. And then the third possibility is just to interchange or swap the position of the rows. And sometimes that's helpful, but it's not always necessary. So as long as we abide by these rules, we'll be fine. So if I'm trying to focus on this position here, and I'm trying to make this into a 0, what is some operation that I can do that I've defined here that will make this turn into a 0?
Multiply by 1.
Multiply what by 1?
Top row.
The top row?
No,
Yeah.
no, no.
But what does multiplying by 1 do?
That won't give you 0.
It won't give us 0. Multiplying by 1 is just going to keep everything the same.
Adding them.
Doing what?
Adding them.
Yeah. Let's just add our rows together. Right? So what I want to do is take my new row 1 is going to be row 1 plus row 2. And this is the thing that you're going to have to be able to figure out on your own. Because if I take the numbers from row 1, which are 1, 1, and 5, and then I take the numbers from row 2, 1, -1, and -1, and I just add them together, I get 2, 0, and 4. And this is my new row 1. Does anybody have any questions about that? That first step. Okay. So I said we want to get our zeros first, and we've gone ahead and gotten this guy to be a 0 just by adding the 2 rows together. But now we want to turn this guy into a 0 somehow. So can anybody think of how I might use these rules to add the 2 rows together to get a 0 right here? Just focusing on the first column. And you'll have to be a little creative here.
Multiplying -2 and row 2.
Yeah. Yeah, let's do that. So like we can break it up into 2 different steps, right? We could take row 2 and then just take -2 times row 2. And let's just do that as an intermediate step. And what this intermediate step is going to do is going to match the x's, coefficients. So if I multiplied this row by -2, what I'll end up with, row 1 stays the same, 2, 0, and 4. And I'll have -2, +2, +2. Right, so just as an intermediate step, we transformed row 2. What would be the next step if, again, we're trying to focus on getting a 0 here?
Adding row 1 and row 2.
Yeah, we're just going to add row 1 and row 2. So I'm going to rewrite this matrix on the back page and give you guys a little bit of time to catch up. 2, 0, 4. -2, 2, 2. -2, 2, 2. Again, we wanted to eliminate this guy. So in order to do that, we can say row 2 is going to be, the new row 2 is going to be generated by taking row 1 and adding that to row 2 now. So we would have 2, 0, and 4, and then we're adding -2, 2, and 2. So this first set of numbers cancels out. So we get 0. 0 and 2 is 2. 4 and 2 is 6. Again, we're just adding. So the resulting matrix is going to change row 2 to 0, 2, and 6, where we have 2, 0, and 4 up here. Any questions up to this point? Okay, well, I forgot what step I'm on. These are our row operations. So first you want to convert the system to a matrix, and then we want to get our zeros, which we've done using our row operations. So once you've gotten the zeros, we can move on to step 3, which is turn these 2 positions. I don't know what I should use here. Use this position and this position. We want those to be 1s. So we can get the 1s. And the easiest way to do that is by just taking this row and dividing it by a number. Or multiplying by a fraction, but I think that everybody is going to want to divide by some number. Well, if I want to turn this first row to have this first position be a 1, what number do I have to divide this by?
Two, 1/2 or 2.
Yeah, I could multiply it by 1/2. I can multiply this first row by 1/2, or I could divide it by 2, however you want to look at it. So just for simplicity's sake, let's say I'm going to take this row and divide it by 2. Well, then I would have 1, 0, and 2 for that first row. Simultaneously, we could take the second row and say, okay, this row, if I want to change this position into a 1, what do I need to divide here? Or what do I need to divide by?
2.
Yeah, a 2 as well. So you get 0, 1, 3. So what is the solution for this system of equations?
2 and 3.
Yeah, the solution is the ordered pair 2, 3, because if I were to take this out of the matrix, what I'm getting is x is equal to 2 and y is equal to 3. So this would be the solution. Does anybody have any questions about this particular problem? Okay. Now I know that that was watching me do a lot of it, right? And sort of gently guiding you to giving me the correct operations. But what I'm going to do now is throw you guys into breakout rooms to work on this next one. So let me give you the system here. 3x plus 2y equals -9. 2x minus 5y equals -6. And I want you to solve by trying to come up with the row operations that you need so that you can get, remember, your goal, which is 1, 0, 0, 1, and then your x and your y, whatever those numbers are. This is what we're aiming for. So 1, get the matrix. 2, get your zeros first. And then 3, get the ones. Okay. Now, I'm sure that seemed really challenging, and part of it is an illusion, part of it is it's new, and part of it is that it is kind of challenging. But once you get it down, the process is what's important. It's going to be hard to like see this scrambling of numbers and figure out where do you go, but it's all written in the matrix. The clue for what you do is written right in front of you. So what I would say is like, okay, if we're going to get zeros, there are 2 steps to getting zeros. And maybe, oh, yeah, we're good. Okay, so let me go ahead and start this off. just so we can see it not so choppy, right? We have 2, -5, -6. Now, the reason why I have you guys get the zeros first is because it's going to help you avoid fractions. The downside of that is that the numbers are going to blow up to really large numbers, and you just sort of have to not worry about that because we'll make them small at the end. So what I'm doing by getting the zeros first is if you get fractions in the answer, it will be in the very last step. You won't see fractions at intermediate steps. But what I was saying to you guys in your separate breakout rooms is like, well, I need to add or subtract these to cancel something out for this first position to get a 0 here. Because remember, I want Swiss cheese. Okay, but 2 and 5, if I just add them straight up, I won't get 0. So this is sort of like getting a common denominator. It's like analogous to that. I'm going to take 5 and multiply it here, but I'm going to take 2 and multiply it down to this row. So it's sort of like 5 times this row and 2 times this row. And that will be my next matrix. So 5 times 3 is 15. 5 times 2 is 10. 5 times 9 is 45. Don't forget your negative sign. Two times 2 is 4. 2 times -5 is -10. 2 times -6 is -12. Now we can add the columns, or add the rows rather, to get the zeros. So if I wanted a 0 in this position, if I add these numbers together, 15, 10, and -45, to 4, -10, -12, these eliminate to 0. I'll have 19, -57 here. This will be the row 1 because that's where I'm trying to get a 0. So we have 19, 0, -57, 4, -10, -12. Any questions up to that point? So somehow we need to figure out how to match the column numbers and then add the rows to get 0. So now we're going to focus on getting, we have a 0 here. We need a 0 in this position. So we need to match the column numbers, again, by sort of taking this 4, multiplying it by the top row, taking the 19 and multiplying it by the bottom row. Notice that they're both positive. So what I'll need to do is take +4 here, because 4 times 19 is going to be some big number, but it'll be a positive number. And if I want to eliminate it, then I need to make this one a -19 on the bottom. Now, it doesn't matter if I put a -19 here or a -4 here, that negative sign needs to go somewhere, but I should only have one so that I have opposite signs. And that's where, because these numbers are going to blow up into big numbers, you might just grab your calculator and do this multiplication, because ain't nobody got time to multiply 19 times 4. That's 76. 4 times 0 is 0. 4 times, God knows what that is, -57, -228. And again, we're just going to go ahead and multiply the second row by this -19. So -19 times 4 is our negative 56, and that's what you're looking, negative 76 rather. That's what you're looking for these guys to match. Negative 19 times negative 10. Be careful with your signs. That should be a positive 190. Negative 19 times negative 12. That should be a positive 228. So we match the column numbers. And then we add the rows to eliminate or to get the zeros. So because we have a 0 here already, we want a 0 in this position. Is that where I am? Awesome. Okay. So when I add these rows, 76, 0, negative 228, negative 76, 190, positive 228. This goes to 0. This goes to 190. This goes to 0. So that's going to be my new row 2. So we'll leave row 1 alone as 76, 0, negative 228, 0, 190, and 0. If in doing all these row operations, you lose sight of what we're actually trying to accomplish, leave the matrix, right? Write this as a system of equations. Because this as a system of equations would be 76x is equal to negative 228. And 190y is equal to 0. And we can solve these, and eventually you get x is equal to negative 3 when you divide that 76 over to the other side. And when you divide 190 to the other side, you get y is equal to 0. So your solution is negative 3, 0. These take a lot of practice, so don't put it off, especially since this is the last set of material that we needed to cover so that we can do the test, right? There's not enough time for me to give you more and more of these examples. So what I highly recommend, and I say this strongly urging you, get in your homework, practice these problems. You're going to see some weird stuff that we weren't able to cover, but make sure you have the time to get in and talk with a tutor in Math World, either myself or one of the other tutors, because the stuff that we didn't cover, the strange situations where maybe you don't have a solution for the system of equations, or maybe you have this weird situation where everything gets eliminated. I think I'll post a supplemental video, but you'll have to work through that with either me in office hours or in Math World hours, or with one of the other tutors, because there's just simply not enough time. But I think that you guys have the groundwork to sort of get in there, play with these weird ass puzzles, and like just get the practice that you need, because it is frustrating. Make sure you take breaks and see me in Math World. Does anybody have any questions?
Is it going to be like super impossible if like the Math World hours just don't work with like work schedules and things like that? Like I leave before I can get into there, and then I get home when it's already over. And my days off are like the days I'm in school. So
for that individual case, I would say shoot me a message and tell me what your like an alternative availability is for you, so we can figure out what we can like, maybe I can shift around some of my office hours to accommodate you.
okay, thank you.
But Math World is open on Saturdays too. I don't know, people work on Saturdays sometimes, so for those of you that don't work on Saturday, it is working on Saturday, or they are open on Saturday. So homework 5.2 is open in MyLabs Plus, but also the review for test 1 is open in MyLabs Plus. Okay.
And we can do the review as many times as we want, just for
Yeah.
practice.
Yeah, the review. When you get in there, you'll see when the review closes. I think it closes the same day that the test will close. So like next Wednesday.
Okay.
Next Wednesday is the test.
No,
Is the test next Wednesday? Sorry.
this Wednesday, I'm going to open up the test in
Okay.
Canvas.
Okay.
But the review will be open as long as the test is open, so that if you need time to work on the review and go into Math World, you'll have that time to work with me or one of the other tutors on the review so that you feel confident going into the test.
Okay.
But again, the test will be open on Wednesday and then close next Wednesday at 11:59 at night.
And how long is the test?
In terms of questions, it's 20 questions long. And I think I put maybe one of these matrix problems in there. Maybe it was just one. No,
But
it
it's not limited time, so you can take your time to do the test, or you have like 1 hour.
No,
to do the
there's
test,
going to be a time
2
limit.
hours to do the test.
Yeah.
30 minutes.
I'm thinking that I'm going to give you guys 2.5 hours to do it. I think that's going to be plenty of time. But I'm going to put out an announcement in Canvas so that you have those like details. But it will be timed. You will only be able to do it in one sitting. So like prepare yourself, prepare your environment, make sure it's like quiet and that nobody's running in the background, no dogs barking or anything like that. No distractions. Yeah, but I will put out that announcement later today with the details for that.
And also like if we can have a calculator, no calculator, all
Oh,
these things,
yeah.
are you gonna write it down to see
So
what we can have?
For the test instructions, those will go up on Wednesday, but typically you're able to use a calculator. You need to show your work on your own Scratch piece of paper because I am going to have you guys upload your work for the test. Now that does two things. For one, it cuts down on cheating because I'm going to see the kind of work in your thought process as you write it down. But two, I go through those things, and if there's like a little sign error or a little mistake that throws off the problem, I give partial credit. So it's a lot of work, and it takes me about a week to get through all of y'all's tests, but it's sort of worth it to get that partial credit back and to get the feedback back to you guys. But like I said, test, I'm in the process of making a handout that you can use on the test. You can use your a sheet of notes, a single sheet of notes. That is your typical 8.5 by 11 piece of paper. No worked examples though, just notes, like little words of guidance that might guide you whenever you get stuck on a problem.
Like the rules and stuff.
The rules, adding, subtracting, multiplying, dividing, fractions. If you need to write those rules down, you could write them down. But like some of those things I'm going to provide to you. So you might, once I post the handout that I'll make for you guys, the test reference, then you can start thinking, okay, what else do I need from my notes? Any other questions?
No. Okay, thank you.
Yeah, I'm gonna put that announcement out with more details. If that is still if you still have questions after that, just shoot me a message. Okay, you guys are free to go if you don't want to spend the rest of the time talking to me.